everyone, welcome to my YouTube channel. I am Lisha studying in Sri Venkateshwara College of Engineering. I am here to explain about the analysis of a completely randomized block design from the subject mathematics, guided by Soumya ma'am. Introduction. A completely randomized design CRD is one where the treatments are assigned completely at random so that each experiment's unit has a same chance of receiving any one treatment. For the CRD, any difference among experiment units receiving the same treatment is considered as experimental error. Hence, CRD is appropriate only for experiments with homogeneous experimental units such as laboratory experiments where environmental effects are relatively easy to control. For field experiments where there is a large variation among the experimental plot in such an environmental facts as soil, the CRD is rarely used. Procedure. The step-by-step procedure for the randomization and layout of CRD are given here for the culture experiment for 4 treatment A, B, C and D. Each replicates 5 types. Step 1. Determine the total number of experiment plots N as the product of number of treatments T and the number of replicants R. That is N is equal to RT. For example, N is equal to 4 into 5, so that's equal to 20. Hence, one pot with a single plant in it may be called a plot. In case the number of replications is not the same for all the treatments, the total number of experimental pots is to be obtained as the sum of replications for each treatment. That is where Ri is the number of times that it treatment replicated. Step 2. Assign a plot number to each experiment plot in any convenient manner, for example, consequently 1 to n. Step 3. Assign the treatment to the experimental plots randomly using a table or a random number as follows. Locate a starting point in the table of the random number. Appendix 6 by closing your eyes and pointing a finger to any position in the page. For example, the starting point is taken at the intersection of the 6th row and the single column, the 2-digit number. Using the straight point obtained, read downward vertically to obtain n is equal to 20. Distinct 2-digit random number. For our example, starting at the intersection of the 6th row column, the 20 distinct 2-digit random number has been shown together with their corresponding sequence of appearances. Random numbers 37, 80, 76, 2, 65, 27, 54, 77, 48, 73, sequences 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Random number 86, 30, 67, 5, 50, 31, 4, 18, 41, 89. Sequence 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Rank the n random numbers obtained in the ascending or descending order. For example, the 20 random numbers are ranked from the smallest to the largest as shown in the following. Random numbers that are 37, 80, 76 and so on. Sequence 1 to 10 ranked from lowest to highest, that is 8, 18, 16 and other ranks. And random numbers like from 86 to 89 which have the sequence of 11 to 20, and their ranks are 19, 6, 14, etc. Divide the n rank derived into t groups, each consisting of n number according to the sequence in which the random number appeared. For our example, the 20 ranks are divided into 4 groups, each consisting of 5 numbers as follows: 1, 2, 3, 4, and ranks in groups are 18, 16, are grouped by 4 digits. Assign the t treatment to the n experimental plots by using the group number as the treatment number and the corresponding ranks in each groups as the plot number in which the corresponding treatment is to be assigned. For our example, the first group is assigned to be the treatment A and plot number 8, 13, 10, 14 and 2 are assigned to receive this treatment. The second group are assigned to treatment B with plot number 18, 5, 15, 3 and 4. The third group of assigned to treatment C with plots numbered 16, 12, 19, 11 and 9, and the fourth group to treatment D with plot numbered 1, 17, 6, 7 and 20. A simple layout of a completely randomized design with 4 treatment A, B, C, D, each replicant 5 times. Randomized complete block design. The randomized complete block design RCBD is one of the most widely used experimental design in forestry research. This design is especially suited for fields experiment where the number of treatment is not large and there exists a conspicuous factors based on which homogeneous set of experimental units can be identified. The primary distinguishing features of RCBD is the presence of blocks of equal size, each of which contains all the treatment. Block technique. The purpose of blocking is to reduce the experimental error by eliminating the contribution of known sources of variation among the experimental units. This is done by grouping the experimental units into blocks such as variability. Within each block is minimized and variability among blocks is minimized. Since summary, both designs are effective tools for experimental analysis but are chosen based on the structure and variability of the experiment units. The CRD is a simple and appropriate of homogeneous setting while the RBD is the ideal when there is expected variability that can be controlled through blocking. Thank you for watching my video. Please like, share and subscribe to my channel.